Hello, I saw your question on the discussion board. What you want to look at is on page 428, 429. I copied this from page 429, and this is table 5 that refers to. And I've kind of circled here, you will determine the degrees of freedom to find the critical values. In this problem, you're given in the directions it's one-tailed. So, looking at this table, it's one-tailed. You're also given alpha's 0.05. So it's one-tailed and 0.05. So this is the column of numbers you need to look at. The only item you need determines the degrees of freedom. And you got two options here. If the variances are equal, use this formula to determine the degrees of freedom. When the variances are not equal, you pick out the smaller of these two. And so I guess if we look at the example where I guess in your question, part A, when the variances are equal, so you're given these two scores, and so you want to add them and subtract 2. So if I do that, that'd be 17 plus 8 minus 2, that's what, 23. So your degrees of freedom, for part A is 23. So you come down here to 23, and you come to this column, and the answer is 1.714, and your problem gives you it's a left-tailed test, and so you need to make that negative. So the answer would be negative 1. Be negative 714. Again, it's negative because the problem gives you it's a left-tailed. Then the part B says the variances are not equal, and so not equal, you want to subtract 1 from each of these and pick out the smaller one. Well, if you subtract 1 from that, it'd be 16. You subtract 1 from this guy, and it'd be 7. So your degrees of freedom will be 7. So you come up here to 7, and then we come across, and it's 1.895. And again, it's a left-tailed test. That's given in the directions. So your answer to part B is minus 1.895. So it's a combination. Using these directions here, and then if variants are equal or not equal, you use these different formulas in your table. So you got to pick out the right columns here, and then figure out to calculate the right degrees of freedom. I hope that helps.